In this video, we solve homework problem 6.2.21 or point 21 from Essentials of Statistics, 6th edition by Mario Triola. The problem statement says, a survey found that women's heights are normally distributed with a mean of 63.4 inches and a standard deviation of 2.4 inches. A branch of the military requires women's heights to be between 58 inches and 80 inches. First, they ask us to find the percentage of women meeting the height requirement. And then it asks, are many women being denied the opportunity, to join this branch of the military because they are too short or too tall? And then it asks, if this branch of the military changes the height requirements so that all women are eligible except the shortest 1% and the tallest 2%, what are the new height requirements? So let's look at the first part first. We're asked for the percentage of women who meet the height requirements. And the height requirements are that women have to be between 58 inches and 80 inches, and we know the mean and standard deviation of this normally distributed continuous random variable. So I'm going to work this out on my paper, and I'll share my paper with you. Okay, so we're here. So that's our mean, 63.4. The standard deviation is 2.4. These are all in inches. And the height requirements are that women's heights need to be between 58 inches and 80 inches. So when they ask us to find the probability of women meeting the height requirement, they're basically asking us to find the probability that a woman's height, a randomly selected woman's height, is between 58 inches and 80 inches. And so let's draw a normal distribution. Wow, I'm having trouble tonight. We're told that the mean is 63.4. So that's right in the middle. And then if I subtract that standard deviation from that, I would be at 61 inches. That's one standard deviation below the mean. And then if I add one standard deviation to this, that would get me to 65.8. So that's one above the mean. Okay, and I'm trying to get to 58 and 80, so I will subtract another standard deviation from here. 61 minus that 2.4, that's going to land us at, what is that, 58.6? Is that right? Let's see. It's about dinner time, so I don't trust my arithmetic skills at this point in the day. I'm subtracting 2.4 twice. Yeah, 58.6. Okay, and then we've got 65.8. That's one standard deviation above the mean. And then we add this 2.4. That's going to get us to 68.2. And so on. But whoa, they go all the way up to 80 inches. So looks like this is what we've got here. I'm just going to continue drawing that out. This was the mean. This is one standard deviation above the mean. This is two standard deviations above the mean. This is one standard deviation below the mean. This is two standard deviations below the mean. But we're going all the way out to 80. So we're going off to this far end. 80 is way over here, just shockingly high in numbers of standard deviations. And then 58, it looks like that's one standard deviation below the mean. That's two standard deviations below the mean. 58 is between that 58.6 and the next one. So I think the z-score that corresponds to that must be negative 2 point something. So let's just put that right there as a 58. X equals 58. So we are looking for this area here between 58 and 80. And it looks like we've got almost all the area, doesn't it? But we don't. There's a little bit in the tail to the left over here, and there's a tiny, tiny bit in the right tail above that 80. But I would expect that probability to be close to 100% or close to 1, because look at the picture. I mean, it's all blue. It's all blue there. So in order to find that, I'm going to take the probability that x is less than 80. So that's the larger one. And I'll subtract the probability that x is less than 58. That's the smaller one. In order to find these two probabilities, I'm going to convert to the corresponding z-scores. I expect that one to be close to -2, a little bit more negative than -2. And this 80 is way out there. I'm expecting that to be over 3. I mean, that's lots of deviations above the mean, just crazy numbers of deviations above the mean, given that our standard deviation is 2.4. But let's convert to prove that. So if I want a z-score corresponding to x equals 80. This is what I'll do. I'll take the x value and I'll subtract the mean and I'll divide by the standard deviation. So I've got my x of 80 and I'm subtracting 63.4 and I'm dividing by 2.4. So 80 minus 63.4 is 16.6. And you're going to divide that by 2.4. It's like, how many standard deviations is that? 6.9. So that is a height of 6.92 approximately, standard deviations above the mean. It's way out there. Okay, so this first probability is the same as the probability that z is less than 6.92. And the second one, that's the one where I think it's going to be a little bit less than that -2, or a little bit more extreme than -2. To do that, we'll take our x value, which is 58, and we'll subtract that 63.4 and divide by 2.4. And I get -2.25. That's more typical. It's still more than 2 standard deviations below the mean, but it's nothing like this 7 standard deviations, nearly 7 above the mean, which is very improbable. It's very improbable to have a woman who is 80 inches tall. That's a tall woman. Okay, so now we just have to find this probability and this probability. We can use tables for this. We can also use Excel, and Excel is more likely to be accurate. So I think I'll do both and see what I get either way. So let's use table A2 first. And I want the probability that z is less than 6.92, and you'll see what happens. We need a positive z-score. Now, the positive z-scores on this chart only go up to 3.5. It says 3.5 and up. Use a probability of 0.9999. Almost 1, but not quite. Obviously, that is not a perfect probability, but it's good enough for us. And then we're subtracting the probability that z is less than -2.25. So we go to -2.25. It's on our negative z-scores page. So there's -2.2, -2.20, 2.21, 2.22, 2.23, 2.24, 2.25. I think that's it. Actually, I think it's the next one. This is 0, 1, 2, 3, 4, and it's 5. There we go. That's the one. So the probability for that one, the probability, that's the area to the left, is 0.0122. That first one was wrong. That was not right. I'm trying to put a big X through it. All right, you get the idea. So according to table A2, this difference in probabilities is 0.999, 9999, 4 nines, minus 0.0122, which gives us 0.9877. Okay, now let's use Excel. We're still going to calculate the same quantities. Excel just might be more accurate. That first probability, the probability that Z is less than 1 or 6.92, can be found this way. I'll clear these out. So we have normal distribution, RM dot dist, open parentheses. Then they want the Z value, 6.92. For a standard normal distribution. And that's what we have whenever we're talking about Z-scores. The mean is 0, the standard deviation is 1. And we say, yes, we want cumulative distribution. That means we just want all the area to the left of that Z-score, Z equals 6.92. Oh, and they have 1 there. And that's because I want to see what it gives me when it gives me as many decimal places as it can. Okay, so there we go. If I want to see the accuracy, I just kept including decimals until it finally gave me something. So it looks like that probability that Z is less than 6.92. So that's the probability that a woman has a height that is less than 80 inches tall. A woman is less than 80 inches tall. A randomly selected woman, then that probability is 0.999999999999774, and so on. That's, as I said before, that's really close to 1, right? So we've got that. And then we're going to subtract the probability that Z is less than negative 2.25. So we'll enter equals NORM. So this is normal distribution. I'm using negative 2.25 here for my Z-score. The mean is 0. The standard deviation is 1 when we're talking about a standard normal distribution. And that's what we're talking about whenever we've got Z-scores. And we want to say true because we want area to the left. And we got that area. It's the same area that we had over here. Now to get a little bit more accuracy, I'm going to add more decimal places. Okay, and let's subtract those. This cell minus this cell. And I get 0.9878. And when I use the table, I got 0.9877. So it's really not that different. If you want more decimal places, you can see to a little bit better accuracy. But that's it. So let's go to my lab statistics and see how it likes this answer. Okay. So in Excel, we got 0.9878. And that's actually an area. It is not the answer to the question that they asked me for. So they said, find the percentage of women meeting the height requirement. So we've got to take that 0.9877 and convert it to a percentage. So you move the decimal over twice. I'm going to show you my paper again. It's a little bit hard to see. But if you move that decimal over twice, that means 98.77% of women satisfy the requirement. Because it includes very tall women and it only leaves out this 1.22% of women at the very bottom as far as their height is concerned. And it's either 98.77% if we use the values from table A2, or it's 98.78% if we use the values from Excel, which are slightly more accurate. But notice the difference is only 0.0001. So that's 1/10,000th off. Not bad, not bad at all. Okay, let's go back. So we've got that percentage, that's what they asked for. They said round to 2 decimal places as needed. I'll use 98.77 from the table. They like that, that's a great sign. And then it says, are many women being denied the opportunity to join this branch of the military because they are too short or too tall? I'd say no. And the reason is because only a small percentage of women are not allowed to join because of their height. All right, now let's answer the second part of the question. Now I've got new height requirements. It says, if this branch of the military changes the height requirements so that all women are eligible except the shortest 1% and the tallest 2%, what are the new height requirements? Okay, so then it says, the new requirements are that women's heights are they have to be at least this many inches and at most this many inches. So we want to get rid of that top 2% and the bottom 1%. Okay, so I will draw a picture. Here's my normal distribution. I want to find out the height that gets rid of that top 2%, that isolates that top 2% from the bottom 98%. And then I also want to find the height that isolates the bottom 1% from the top 99%. So we need to find the z-scores corresponding to each of these areas. And then once we find the z-scores corresponding to each area, we can convert them to the heights. So let's do the x minimum first. First, I want the area to the left to be 1% of all of the area. And if you move that decimal over twice, you get 0.01. So this is what I need to see in the body of that table if I am looking for the corresponding z-score. So let's go to the table now. Obviously, z is negative because it's separating the 1% from the top 99. So we're over here on the far left. And I want the entry in the table to say 0.0100. I'm going to look for it. .01. Oh, there it is. You see it? Kind of hard to see sometimes. There we go. That's as close as you can get, 0.0099. All right, and that corresponds to z equals negative 2.3. And then we're in, this is 2.30, 2.31, 2.32, 2.33. So z equals negative 2.33. Gets us as close as we can get to negative 0.1 using our table. Now I want to show you that we can get the same answer or a very similar answer and a more accurate answer if we use Excel. So this time, know that we want a z-score corresponding to an area. So we've got to use that normal S INV. So that's the standard normal distribution, but inverse, open parentheses, and you want to put the probability to the left in there. So that's 0.01. And so we get negative 2.3 0.26. And if we round a little differently, round to 2 decimal places, oops, we get negative 2.33, which is the same thing that we got from the table. Okay, now in order to find the x value that goes with this, we've got to convert. This is a number of standard deviations below the mean. So we need to find the corresponding x value, we take that number of standard deviations and then we multiply by the actual standard deviation for a distribution, and then we add the mean. So we get negative 2.33 times the standard deviation, which was 2.4, remember from the problem statement. And the mean was 63.4. You want to multiply and add. Negative 2.33 times 2.4 plus 63.4. And that would give us a minimum height of 57.808 inches. And I believe they wanted us to round to 1 decimal place. So let's look at that. Yes, round to 1 decimal place as needed. So that's 57.8 inches. Okay. And then we need a maximum value, and that is the x value that separates that top 2% from the bottom 98%. So this is for the max. That's 2%, that's 98%, so we need area to the left to be 0.98. If we want the corresponding z-score, and that's what we need a z-score that goes with this x value, and then we can find the corresponding x value. We can look for an area of 0.98 in our table. Since 98% of the area is to the left, we know that this is a positive z-score. Since that's more than 50%, z is positive. Okay, I'm looking for 0.98 in the body of the table. And we want to get as close as we can. 0.98, 0.98. I've got 0.9798, so that's 0.0002 off from 0.9800. Then I've got 0.9803, so that's 0.0003 off. So this is the one. This one right here. Now I just need to find the z-score that goes with that. So I'm going to come over here. Oops. I always do that. There we are. Let's get rid of that annotation. But I am, oops, I don't want that either. So I'm in this row. Z equals 2 point something. And then we're in this column. 2.05, is that right? Make sure. 05, yeah, 2.05. So z equals 2.05 according to table A2. That's one way of doing this. Now the other option is to use Excel. So we want the area. So we'll use, you're going to type equals NORMS inverse, and then you want the inverse of this area. Basically, it's for the standard normal distribution, and rather than giving them a z and then asking Excel to give you the area, we're giving them an area and we're asking for the z. That's why they're saying it's the inverse. So we'll type that in. And then we'll see what Excel gives us. And Excel gives us a slightly more accurate answer. Oops, I forgot to share my screen. There we go. So I type equals NORMS, INV, open parentheses 0.98. I get 2.05, which is the same thing that I got using the table. So that's great. Now, those are z-scores, but we wanted x values. So we've got to convert. We want the height that is 2.05 standard deviations above the mean. To find that height, we take our 2.7 or 2.05 standard deviations, we multiply by the size of a standard deviation, and then we add the mean to that. So we have 2.05 times the standard deviation, which was given to us in the problem statement. It was 2.4 inches. And then we're adding the mean, which was 63.4 inches. And I get 68.32 inches. And they want us to round to 1 decimal place. So I'll round to 68.3 inches. Okay, let's go back. So it's 68.3 inches. So those are the new height requirements. All of the women will be accepted as long as they are at least 57.8 inches tall and at most 68.3 inches tall. And that's it for that question.